Okay, good morning, everybody. Today we're going to talk a little bit about making conversions and ratios and percentages and proportions. And they're all sort of related and they come up a lot. And we want to go over one of the main ideas when you solve a proportion. So all a proportion really is a fraction that's equal to another fraction. And sort of similar to the way we discussed the other day, if you took two fractions, like 5 out of 8, for instance, and 15 out of 24, you can prove that they're equivalent fractions by taking the cross product. I believe that was the term we used the other day. By multiplying across, if we get the same answer, then those fractions are equal to each other. So if you multiplied 5 times 24, would that equal 8 times 15? And if you get out your calculator real quick, you can end up seeing that 120 is equal to 120. So the theory works, is I guess what I'm getting at. Now, usually when you solve a proportion, you're not staring at two fractions like this, where everything's an integer. Usually there's a variable in there, or an algebraic expression. So instead of really seeing 5/8 over 15, let's use the same two fractions, but let's say I said, well, 5 over x is going to equal 15 over 24. This would be a realistic time when you'd actually use this idea. So because they are equal to each other, we're allowed to cross multiply, and we should still get an equation. So in other words, if we multiplied x by 15, that would be the same as 5 multiplied by 24. Now we did all the math up here already, so it's not going to be a surprise on the right side. Anytime you take an integer and multiply by a variable, you can just put it out front. You always see, they call that the coefficient. And so 15 will just be out front. And just, maybe this wasn't clear earlier, but anytime you see an integer up against parentheses, it's implying that you multiply what's in there. More to come on that. So anyway, if we were going to solve this, you could have done it a couple different ways. You could just say divide by 15. I'm going to write it this way again, though. So I'm just trying to tie it to our talk about fractions, but you can divide by 15. That's the same thing. Multiplying by the reciprocal cancels out. So over on the right here, you'd get 120 divided by 15. And x is going to end up being 8. So proportions, nothing to it. All you really need to do is cross multiply and divide. Yeah, I'll go ahead and say that. That's what my one of my teachers told me way back in the day, and as long as it's a simpler proportion, that's true. So we'll try another one here in a second where we got to do a little bit more. All right, so 3 quick examples. We'll even break out our trusty calculator. Don't be ashamed to use the calculator. It's okay. It doesn't make too many mistakes. All right, so if we had to solve these 3 proportions, we'll just start at the beginning. X divided by 7 equals 40 over 56. We could take our cross product. So cross multiply and divide was the motto, right? So in other words, 56 multiplied by x should be the same as 7 multiplied by 40. Or 56x is going to equal 2,800. Or excuse me, 280. 2,800. All right, so anyway, 7 multiplied by 40. Carry the 0. Yeah, that looks good. So the last step, we can just go ahead and divide by 56. Okay, and so you can write that step out. Sometimes you'll see it's a little easier to actually not write all 10 steps down and follow your work. But if you just took 280 here and we divide by 56. It's like x is going to be 5. Okay. Sometimes on a proportion, there's an easier way. So here's a little trick, since we know some things about equivalent fractions now. Two fractions are equal and you find a common denominator, you always multiply top and bottom by the same thing. So I guess what I'm getting at here on this one, and this might seem a little weird to you, but see if you can follow me here. To turn 7 into 56, all I'd have to really do is multiply by 8. So whatever x is, I'd have to multiply it by 8 in order to get 40. It might even be easier to think the other way. What do you divide? If you divide 56 by 7, what do you get? You get 8. All right, so what's 40 divided by 8? X is going to be 5. So as long as all the 4 pieces in your proportion are whole numbers and you can turn one value into the other, a lot of times you can do a shortcut like that, where that would work for us on C, but it would be hard to do. And on B, it wouldn't, because we'll get a decimal or we can get a fraction here. So on B, if you did the same thing, 2 multiplied by Z, that's a Z, by the way. 2 multiplied by Z, I'll stop using Z, that's not a good one for me. It's confusing, sorry. It's 3 multiplied by 21. In other words, 2Z is 63. So this one won't divide evenly. We got an odd number divided by an even. But if we put it in there, cutting it in half, looks like it's going to be 31.5. All right, one last quick one. 945. If I saw one like this, I would just go straight to the calculator. Don't waste a lot of time trying to do some mental math here. So 3 multiplied by n is going to be 4 multiplied by 945. Let me put that in the calculator where you see it. All right, 3780, huge number. We're going to divide it by 3. But remember our rule real quick. 3 plus 7 plus 8. You add all that up. That looks like you're going to get 18 there, right? So this must be divisible by 3. Hey, how about that? It worked out. So it looks like we're going to get 1260 there. So 3n ended up being the same as, what does that say? I'm sorry, 3780. And then we divide by 3, we end up getting 1260 for a result. So there you go. Doing a proportion, no big deal. Cross multiply and divide. And even when you get a linear equation, which is what we're going to be talking about real soon here, it's not too much different. All right, so there you go, proportions.